Coming in hot with question 9. Okay, we need to determine with reasons any three other angles equal to D1. D1 is 37 degrees and it's sitting over here. And I can see D1 is nested inside a bow tie, my friend. And the theorem that is known for the bow tie is angles in the same segment. So we've discovered our first other angle equal to D1. It's A2. A2 will also be 37 for this reason. Angles in the same seg. And we simply just write that up like this. We show the two angles we recognize are equal due to angles in the same segment, and then we state their size. Okay, on to the next one. Okay, now this is where this piece of information becomes very important. The line BA is going to cut angle CAD perfectly in half. So it's a very snooty way of telling you that angle A1 and A2 are equal. It's saying this orange angle is going to be cut perfectly in half by this green line, and you're going to get 37 for A1 and 37 for A2 over there. Can we write that up just like this? A1 is the same size as A2, which are both 37 degrees, and we knew that because BA bisects the angle CAD. And now I smell some sneaky weasels. There are some radii in the mix. They're a bit hard to see. So I see 4 radii actually. So let's start off with these two radii, FA and FC. So if they're equal in length, it means that the base angles must be equal. So C2 will also be 37. And we simply just show the relationship between the two. A2 equals C2 equals 37. And our reason is angles up equal sides. That's a property of an isosceles triangle. And lastly, I'm going to do you one better. I'm going to get you a fourth angle equal to D1. So I see another isosceles triangle over here. So AF is a radii, FD is a radii, which makes this orange triangle an isosceles triangle. So D3 will also be 37 degrees for the same exact reason, angles up equal sides. And quickly have a look where our 4 marks come from. First mark comes from the statement over here, and the reason for angles in the same seg gets you your second mark. And then you get 2 marks for any of these 2 statements. I went a bit above and beyond getting 4, but I like to go a bit above and beyond with Euclidean. It always helps. Next up, we need to show that DG equals GC. Now I'm noticing that DC is a chord. So if I prove that this line from the center is perpendicular to the chord, it'll prove what they're asking me to do. So I want to get G1. G1 should be 90. So to get G1, I'm going to target this triangle, because I already have one angle inside of that triangle. So all that's left is I need to get D2. And that's where this piece of information becomes important. AB is a diameter. So if I follow my diameter down from either end on the circumference, it's going to take me to a 90-degree angle because of angles in a semicircle. So if I know that the whole of D is 90, I can quite easily calculate D2 because I've got D1 and D3. So let's go ahead and jump into that statement and reason. So I'm going to state that D2 equals 90 minus 37 minus another 37 because all 3 of these add up to 90. So it stands to reason if I take the 37s away from 90, it's just going to leave me with the size of D2. And don't take chances, straight in the calculator. So we slap that in there, clap it equals, and we get 16 degrees for D2. And now we're going to come back to this orange triangle to get the size of G1, simply using interior angles of a triangle. All of them need to add up to 180, so it stands to reason that G1 will be 90 minus this big angle minus this 37. Okay, and I know exactly what this is going to give me. It should give me 90 degrees, but double check just for comfort's sake. And you see that it claps me the 90, boys. And now that we have G1 to be 90 degrees, we can actually leap to our conclusion that DG is the same size for GC for the following theorem. Line from center perpendicular to chord. If I have a line running from the center, that is perpendicular to my chord, Then the chord is bisected, it's cut in 2 equal parts. So DG equals GC for this reason, line from center perpendicular to chord. And I simply just write up my conclusion like this: DG equals GC, line from center perpendicular to chord. And then quickly having a look where your 4 marks come from. Reason over here, the statement for D2, the statement for G1, as well as the reason for your conclusion. And the last question here gives us the radius to be 20 units, and with that we need to calculate the length of BG. And how we're going to do that is with our 90-degree triangles. We're going to use SOHCAHTOA. So if the radius is 20, then the length of DF is 20. And then what I'm going to do is use SOHCAHTOA to work out this side, FG. So we're going to be working in this triangle, DGF. And in that triangle, I have the hypotenuse. You see how the 90 degrees points to it? So I need something with hypotenuse, so I'm going to be using sine or cos. And now I'm going to analyze what I want. I want the side FG, which is opposite to the angle. So I want opposite in the mix, so we're going to be using sine. So we're going to start this process off by saying sine of 16 degrees equals the opposite side, which is GF. So we'll go ahead and change that to GF. And the hypotenuse of that triangle is 20. So let's change the hypotenuse to 20. And then what I do to get GF on its own is I multiply both sides by 20. So it kind of sneaks its way in front over there. And that smells like a calculator problem to me, boss. Okay, chuck that in, press equals, and we get 5,51 units for GF. Okay, so now we're almost at the finish line. So you see the line BF, it's a radii, my bro, and the radius of the circle is 20 units long. And if this whole line is 20, just to get the green one, I can say the purple one minus the orange one, 20 minus 5.51 will give me the length of BG. Even though it doesn't look like it, they don't draw it to scale to purposefully confuse you in that way. So let's go ahead and get BG now. And at the end of the day, we get BG to be 14,49 units. And then our 4 marks come from the trig ratio used over here, the correct length of GF gotten over there, and 2 marks for the correct answer, 14.49.